So here is my second refrigeration system. Now it consists a this more like a refrigerator fashion style compressor, because the other one just pulls horrendous amounts of power, and it was really loud and it was just annoying to use. So I swapped on this. Also, now the condenser is a water cooled. There is a 6mm copper pipe in helical shape, like twin helical, inside this jar. It's all soldered and it's watertight, although it does look really bad, like the soldering quality, but it's good enough. And this is my evaporator, and it chills down this water glycol solution, which is moved by this pump right here. And yeah, let's just turn it on. Now the pump is running and the liquid is flowing through this cold plate right here, and in this evaporator it's already frosting on the bottom. It's really cold, and the condenser line is a bit warm, but the outgoing is nice and cold. It's just warming up this water right here. There is no flow through it right now, but I won't be running it too long. Oh, this is actually, my fingers are sticking to it already. And the temperature of this cold plate right now is, when this stupid thing can focus, is around 10 degrees and dropping. And the evaporator itself is...
There is actually a problem with the moisture in the refrigerant. Because the tip of the capillary tube is inside the low pressure and cold heat exchanger, the moisture in the refrigerant freezes inside the capillary tube and blocks the flow of refrigerant. That is why I can't make use of the capillary tube heat exchanger, because the moisture in the capillary tube might frost.
So now it has been running for like about 2 minutes. Its power draw is about 160 watts. The high side is pretty hot. The low side is pretty cold, as we can see, and our cold plate is just about starting a frost. There's some ice rolling here and around here. It's about 0 degrees Celsius right now. So this thing is working, the heat exchanger is working. It's frosting up right here and right here as well. So I should wrap this capillary tube around this outgoing pipe or the heat exchanger itself, and insulate it with, for example, Armaflex or something like that. But it seems to be working. So this setup has been modified slightly from the beginning, but now we can see that there is a actual water cooling on the condenser, because it was getting pretty toasty. And now it's around 26 degrees Celsius, the water. But this thing right here is actually pretty frosted. We are out of the scale on my meter, because this thing only measures around minus 15 degrees Celsius, and by the look of it, it shows about 18 degrees Celsius, but I don't know if for like the scale of this thing it's minus 18 degrees Celsius, but it might be something else. We can also see that the evaporator is pretty frosted, and there is a snow on the copper line, and there is our like vapor line, because the compressor is kicking up it's kicking some heat, and this thing is around 0 degrees Celsius right here, because there is no frost around there. It's the high side is actually pretty toasty, but after the condenser it's around 26 degrees Celsius by the meter. And I guess that this is the lowest that this system as now can get. It does work. Yeah.
I accidentally lost some of the pictures from the making of the heat exchanger, but it is made out of a old copper water pipe. First I got small sections out of it so I could make the end caps for the heat exchanger, because I can't find a supplier for the copper sheet. I cleaned the copper parts with steel wool and some sandpaper. There is 9 pieces of 6 mm copper pipe going through the heat exchanger body. The water/glycol mixture will flow inside the small tubes, and the shell of the heat exchanger is filled with the refrigerant. On the other end of the heat exchanger are just all the pipe ends and then small space so the water can flow through the tubes, and in the other end there is a terminations for the water pipes to connect. All the joints are soldered with lead-free soft solder.